If a vector and b vector are constant vectors, w is a constant and r vector is a vector function having the scalar variable t, then if r vector is defined by this, we need to show these two results. So first, for r vector, we need to show this first result. It is the double derivative of r vector. Let's find out first the single derivative, the first derivative of r vector, that is d by dt of, we have to derivate r vector with respect to t, and we know that a vector and b vector are constant vectors, so their derivative with respect to t is 0. Obviously, these are the constant vectors, it is given to us. So now derivating this first term, according to the formula, we have the first function derivative of the second one plus second function derivative of the first one. Similarly, second one, first function derivative of the second plus second function derivative of the first one. So writing here, because derivative of a vector is 0 because it is your constant vector. So this first term is 0. From second term we have, derivating this with respect to t, we have minus sine of wt multiplied with w. Then plus this term is 0, b vector is a constant vector, and then b vector multiplied with derivative of this. So this is cos of wt multiplied with w. So this is your first derivative of r with respect to t. Now we need to find the second derivative of r with respect to t, that is d by dt of dr vector by dt. The first derivative of r, what is that? This one. So this is minus a sine wt, this is a vector multiplied with w, plus b vector cos wt multiplied with w, right? Okay, because minus a vector, this is a constant vector and we need to derive with respect to t, sine wt again, and also w is constant, I am taking this outside. So derivating sine wt, so we have cos wt multiplied with w, plus b vector is constant, w is also constant, derivating cos wt with respect to t, we have sine of wt with negative sign, and also w is multiplied with this. So this is equal to, if I take minus sign outside, we have a vector w square cos wt plus b vector w square sine wt. Let me also take this w here outside. So this is a vector cos wt plus b vector sine wt, right? Okay, let's put this value over here. So the double derivative of r is added with w square r vector. So putting the value of this is your double derivative of r with respect to t, and its value is, I am writing over here, minus w square into a vector cos wt plus b vector sine wt plus w square is multiplied with r vector. What is r vector given to us? It is this, that is a vector cos wt plus b vector sine wt. It is same as that of this double derivative. So these two cancelled out and we are going to get this answer to be 0. So we have shown that their sum is equal to 0. And now the second part. Okay, LHS, what is r vector cross dr vector with respect to t? So r vector is, it is given to us that a vector cos wt plus b vector sine wt taking its cross product with its first derivative, and we have calculated the first derivative to be this one, minus a vector w sine wt plus b vector w cos wt. And now we need to take the cross product of this. A vector cross product with a vector. What is the cross product of the constant vectors with itself? Because its magnitude is equal to mod of a vector sine of theta, the angle between the same vectors, because we are taking the cross product of the vector to itself. So angle is 0 over here. So sine theta, that is sine of 0 degree, which is equal to 0. That is why its cross product is 0. So the cross product of the same vectors is 0. So a vector cross product with a vector is 0. And we also have the negative sign over here. Cos wt is multiplied with sine wt. These are scalar functions, so it is cos wt multiplied with sine wt, also there is w. And now taking its cross product with this, first with this and then with this. So we get, okay, we have to write this as a vector cross product with b vector, that's it, and multiplying cos wt with cos wt, that gives cos square wt, and also there is w. Then taking the cross product of second term with the first term, it is negative sine b vector cross product with a vector, and also w is multiplied with this, and we have sine square wt. And then taking its cross product with the second term, because we know that cross product of b vector with b vector is 0, so I am writing it as 0. This first term is also 0. So what we are having, if I take w outside, it is a vector cross product with b vector cos square wt minus, how do I write b vector cross product with a vector as negative of a vector cross product with b vector. A cross b is negative of b cross a. Please remember, if we have the dot product, then there is no change of sign. But if I am having the cross product, we have the negative sign with this b cross a, right? So using this, we have the negative sign over here, the remaining sine square wt. Minus minus gets to be as plus. So we have same cross product in the bracket. Let's take this outside of the bracket. We have w into the cross product of a with b vector, and inside we have 1. So we have the left hand side to be w multiplied with a cross b vector. So this is the LHS, the left hand side. And yes, this left hand side is equal to this right hand side. It is w multiplied with the cross product of a and b, right? Okay, let's move on to one more example. If r vector is sine hyperbolic t into a vector plus cos hyperbolic t into b vector, where a vector and b vector are constant vectors, we need to show that the double derivative of r vector is equal to r vector, the vector itself. Okay, so let's take the first derivative of this. I'm straight away taking the derivative now. This is the constant vector. Okay, derivating this with respect to t. So it is cos hyperbolic t plus B vector derivating cos hyperbolic t with respect to t, it is sine hyperbolic t. These are the harmonic trigonometric functions. Similarly, now taking the second derivative, what is that? It is d by dt of, that is the derivative of the first derivative, right? Okay, derivating this with respect to t now. A vector derivative of cos hyperbolic t is sine hyperbolic t, plus b vector derivating this, we have cos hyperbolic t. That's it. Okay, now this is your second derivative. Is it equal to this r vector? Yes. So writing this further as this is equal to r vector. So we have shown this result also.